In this video, we're going to go over encryption, which is the process of encoding messages in a way that only authorized parties can read our message. So for example, if I'm sending a message to another user, I'm going to use some kind of encryption algorithm to obscure the content of this message. Therefore, if a hacker actually gets in and obtains this message, they won't be able to read it because it's got an encrypted content. So the only way they'll be able to read it is if they have the decryption algorithm. So the receiver is going to use the same decryption technique that I used to encrypt the message in order to receive the message. So the way that this is going to work with databases is that we might use hashing. Now hashing is different than encryption because encryption is reversible. Hashing, on the other hand, is going to compute a value based off of the input value and the hashing algorithm, and then it's going to store that value in the database. This value is irreversible, meaning that I cannot go back to the original value because the way that the value is calculated. So let's look at an example of how this might work. So if I give you the input 1, 2, 3, 4, 5, and the algorithm is to multiply that by the zip code, we're going to get 1, 2, 3, 4, 5 times 68178, and we're left with the number of 841657410. Now this is using an encryption technique that is reversible, whereas hashing is going to use an irreversible technique, which we'll show you on the next slide. Salting, on the other hand, allows us to add random bits to the inputs before we actually begin the encryption technique or the hashing technique. So for example, if we want to add a salt of 782, we add that to the input and then we multiply that by the zip code, which gives us a different number of 894972606. So the examples of hashing that we see here are right in line with what I'm talking about. You notice here we have digits that are in hexadecimal characters, meaning that they go from 0 to 9 and then A, B, C, D, E, F. So here we have 32 character password that is generated by an MD5 algorithm, as you can see. So for example, the MD5 of the password is going to be this hashed value. Now, since it's a hashed value, I won't be able to actually reverse this back to the original password. Now, there are other ways to break this, such as dictionary attacks or brute force attacks. Then we see over here SHA-1 generates 40 characters, so it's a little bit better, but both of these techniques are a little outdated and they can be cracked in a short time period. So there are other hashing algorithms that are much better, such as SHA-512, which has 128 characters, which makes it much more difficult to crack. So this is only used in PHP or other programs. MySQL doesn't really support it directly. So in order to do it with PHP, we would say hash and then specify the algorithm we're doing, which is SHA-512, and then the actual password that we're going to hash. You can salt with crypt using PHP as well, so we'd say crypt and then the pass and the salt, we would join those together. We could also combine the username and password before we actually hash it, so we're going to add the user and the password together as one string and then go ahead and hash that. Now, the best way to do this is not to combine the username and password. What I have done on this server is I've generated a random salt for every single user. This salt is hashed with SHA-512 encryption, and then what I'm going to do is add that hashed value to the actual password. Then I'm going to hash the password. So it's basically I'm taking your password, adding 128 random bytes to the end of it, and then after I add those 128 bytes, I then hash it one more time, and then we're left with just the 128 bytes as your hashed value. Since this salt is unique to every user, it's going to be a lot harder to crack that password. What I want you to do is try to hash your own password that you use for this database class using both the MD5 and SHA-1 algorithm. So go to MySQL Workbench and try to hash that and then come back and see how we did this. Alright, welcome back. So what we're going to do is we're going to select the MD5 of our password, and let's just do password in this case. And then I'm going to run it, and we see the hash value is 5F4DC. And if I go back to the slide, you can see that we have 5F4DCC 3B 5AA and so on, which matches exactly what we just got. So I can also do the SHA-1 right here, and I'm going to run it, and we get 5BAA as the hashed value of the SHA-1 password. I'm going to go back, and as you can see here on the slide, that matches what we have in the second row.